This is a video to teach you about Newton's second law, which is the mathematical relationship between force, mass, and acceleration. The goal of this assignment is to help you practice collecting and graphing data, learn that mathematical relationship, and then be able to apply it to some of these practice problems on the back. So what I'm going to do in this video is I'm going to show you how to set up this simulation, and then I will walk you through how to start collecting data for this particular question. How does force affect acceleration? And get you started with graphing. You will then be able to finish up the rest of the data collection, find the mathematical model once you have all of the data, answer that question, and you're going to be entirely on your own for part B, how does mass affect acceleration? Once you have those two together, you'll have a pretty good idea about how to manipulate these three variables and be able to rearrange them for these different story problems here. So let's go ahead and get started. Let's go ahead and you're going to have to type in this. Make sure that you have the capital F, A, and M on there. Go ahead and click play when you get to this page. And let's go ahead and walk through looking at the directions. So open the acceleration section. That's going to be right over here. Check all the boxes. And you're going to be changing the force for the first column and change mass for the second column. So you'll be able to change the force, the applied force, over here by pushing with different amounts of force on the box. And when you are finished with this, in the second one, you'll be changing the amount of mass of the box. So you'll be able to add additional mass by putting things on here. Okay, great. So for this first one, we are focusing on this question, how does force affect acceleration? I want to make a note here. The applied force is the pushing force. So that's this orange arrow right here. I'm showing that I am applying a force of 100 newtons. The net force is the sum of all forces. This is the sum of all forces. Now you can tell that there's currently zero net force on this box because we have this opposing friction force that's equal to the applied force. So currently the net force on this box is 0. We can go ahead and I'm going to go ahead and record this as my first data point. So I can say my applied force is 100. I don't know why it's doing that, but you'll have that looking good. The net force is 0. And the acceleration, which we can see right here, is 0 meters per second squared. So our acceleration is also 0. Now I want to note, because I kind of jumped ahead a little bit, our value of controls in this moment, we have a mass of 50 kilograms. That's the mass of the box. And there's something else that we need to be keeping the same every single time. We're changing the applied force. Everything else should be staying the same. I'm going to give you a moment to think about that. And then I'm going to tell you the answer so that I make sure that you have the right stuff. So I'm going to give you the answer in a count of 10. Think about what else we are keeping the same in this scenario. Okay. The other thing that we're keeping the same is this friction. If I were to change that friction, it would change the amount of force that it takes to finally get it to start moving. I'm going to go ahead and reset that. We want to keep the friction the same the whole time. So the other controlled variable is the mass and friction, which we're going to keep at a medium level. So those are our two controls. Now we've got our first data point. I'll go ahead and apply that same 100, and I'm just going to continue to go up by 50s. So when I get to 150, I can see that now I'm starting to accelerate. I'll go ahead and pause so this doesn't get out of my way here. But my sum of forces is 56 newtons, and my acceleration is 1.12 meters per second. So my applied force was 150. My net force was 56 newtons, and my acceleration was 1.12. Okay, I'm sorry about my formatting here. So you're going to need to collect 3 more pieces of data. And then you're going to go ahead and graph this. And you're going to graph it by going to, you can do the graphing by hand, but you will probably need to go to this Desmos link anyway so that you can get the mathematical model or the equation. So I'm going to go ahead and I get the privilege of just copying and pasting this in. Again, it's case sensitive, but this will take me to a Desmos calculator that already has these formulas put in there. So I'll go ahead and put in my data. And then once I have my data, I'll be able to move this slider along until I find a line that goes through my data. That's going to help me to be able to determine what the relationship is, because whichever line goes through, I'll be able to delete out the other lines, and that'll tell me my relationship, and that'll tell me exactly what I'm supposed to write right here. Okay. Once you have your mathematical model, you will be able to answer this. What we're looking for right here is the explanation of the particular relationship. So we're looking for the word horizontal, proportional, inverse, or quadratic to tell us what relationship there is between force and acceleration. And I also want you to explain why we used the net force instead of the applied force. If you're not sure, go back to that section of my video where I talked about that. Once you're done with that, do the same thing for part B, but now you're going to be changing the mass and you're going to be keeping the force the same every time. So your applied force will be 100 newtons, and then you want to turn friction down to none. There's this note right here. After you've collected your data, complete these math problems. Have fun, and hopefully you'll better understand how force, mass, and acceleration are related to each other.